the wrong way. All right, so who in here did not sign up for the hackathon? You didn't sign up. Oh, that's right. Who in here meant to sign up for the hackathon but didn't sign up for it? Okay, good. His deadline was 4 p.m. yesterday. And I'm not taking any late people because teams are going out today. All right. Let's see. What was did we do an Eclipse? Android. Android. All right. Ah, that's right. We had buttons. It was awesome. Oh, here it is, right here, Mergesort. All right. So first of all, how many of you, at the very least, should have still been a challenging assignment, right? How many of you felt like it was more in your wheelhouse this time than it was a year ago? Felt like you had a fighting chance at this one this time around? So you've noticed improvement? How many of you didn't notice any improvement? It's like, no, it was actually worse this time. Last time I didn't even know how to start. This time I felt like I should have known how to start, and then I felt stupid. Like I felt like I was getting really good at programming until this assignment. And then it's gone. Exactly. All right, so I want you to remind me of a few things. How are arrays passed the function? Are they passed by value or passed by address? Address. Okay, they were passed by address. And what does that mean?
You don't need to return the array to keep its value.
Okay, that's true.
Passed by address, I mean change like directly in the arrays.
Okay, so changes made within the function have a lasting effect. All right, a lot of times books will call this side effect. They have side effect, meaning that if we alter that array inside the function, that change will be permanent. We don't have to return the array. Okay, those changes are made up there in memory because we passed a pointer to where that guy actually lives. All right, now, remind me, what is recursion? All right, let's go with no-show Luke. Okay, it's when a function calls itself from within itself. When a function calls itself. No-show Luke. I have to work on that. There could be something like we come up with a little spin on that. That could be pretty good. Please have mercy. All right, so when a function calls itself from within itself. So Harold, let me give a little follow-up. Why is recursion hard? Most of you, I'm assuming, find recursion somewhat confusing, right? You won't after 470, but why do you find recursion hard? Oh, just cause? It's just hard because, it's cause. Go ahead.
For me, I think it's kind of hard to visualize the new input that's going in once you recall it.
Okay, so kind of when we have multiple layers, multiple calls of the same function, it's hard for us to keep track in our head what the current version of the input is. Okay, so let me. Why do we write functions? Any kind of function, recursive functions, normal functions, blah blah blah. Why do we write those? Okay, so we write it once, call it multiple times on different inputs, typically. Yeah, all right. So the idea is that we write functions generically. So it does not matter what the input is. We are solving, well, let's see, we are writing that function to operate on whatever that input currently is. So my follow-up question here would be, when you're working within, when you're writing a recursive function, do you need to worry about what the other inputs to the other calls, in our case here, merge sort was? Or do we just solve the problem that's in front of us? We have inputs, right?
Mhm.
So a function, whatever that function is called, whether it's merge sort, whether it's whatever, we have some inputs that came into that function. Now this might be our 15th call to this function, right? But all we're writing is a generic solution to solve the problem at hand based on the inputs that this call has. Does that make sense? We don't have to worry about all those other calls. We have to trust ourselves that we called this function with the right inputs. Does that make sense? So if we're dividing up our array over and over again, and each time through we're passing the same array, the same array, the same array, what we're actually differentiating is we're saying, I'm going to say, I want you to focus on bucket 0 to bucket 4 of this array. And then maybe another call says, I want you to focus on bucket 5 to bucket 8 of this array. It's the same array. We're just changing which aspect of the array we want that particular iteration through the function to focus on. That makes some sense? So we're not solving the global problem of trying to solve all of merge sort inside of a single call to merge sort. We're only interested in what the inputs tell us we're interested in, what portion of that array we're interested in. That makes some sense? All right, so and this kind of goes back to when you first started programming. Your weakness when you first started programming was breaking problems down into tiny steps was a challenge, right? You know, you kind of wanted to jump in and you wanted to solve the entire problem. And then you dive in, you start typing on the keyboard and nothing works. You get 1,000 errors and you got so many you can't even fix them, and you're at a point where it's like, it doesn't matter what I changed. And then sometimes you just start randomly changing stuff and hope for the best. Now you're going down a real dark path, right? So then you started getting used to maybe drawing some stuff, writing some stuff on paper first. You know, V here has what, 15, 16 pages today? How many pages did you say you had? 15? Well, no, it was impressive. She wrote a whole bunch of stuff down on paper to plan this thing, right? So we get used to writing stuff down on paper before we just dive into the code, because that helps us plan, right? Especially when we were dealing with linked lists. If we hadn't done that, we would have gotten some sort of permanent double knot in our brain, and we'd all be walking around like vegetables, right? We wouldn't function anymore. We needed pictures for linked data structures. All right, so when we write merge sort here, let's go take these pieces away. We're going to have our entire array. All right, so we're always going to pass this array around to all of our calls to merge sort, not portions of that array, okay? Not new copies of that array. Because we pass new copies of the array, now we have different memory addresses. And changes we make to that copy will not have a permanent change to the original. Make sense? We're going to pass this one array around over and over again. But what we're going to change is which part of the array we're interested in. So maybe one call to merge sort is specifically going to take in two values, begin and end, that focus on which subsection of that array are we actually performing merge sort on this time around. And maybe the second call will be for the second half of that guy. So all that's changed to those two merge sort calls is we've passed the exact same array, but the first time through we passed the integers 0 and 1, and the second time through we passed the integers 2 and 3. Because begin and end were different. We were focusing on different parts of the array that time. knowing that any changes to the left-hand side, we're going to have permanent side effect to this guy here, right? And that was not going to affect this part over here because we weren't focusing on that side of the array. All right, so I'm going to come in here and I'm going to create a little Mergesort helper. And what Mergesort Helper is going to take is an integer AR, so my entire array, as well as an int begin and an int end. I don't like how that comma is there. There we go. I'm much happier now. All right. This is always going to be my original array I'm passing around. Always, 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 always. But these guys are going to dictate which portion of the array this particular call to merge sort is looking at. Does that make sense? So from this point forward, when I write Mergesort Helper here, I'm writing a generic function. This is a function that will work for any three inputs where we have an integer array and a begin and end. Specifically, I'm looking at this array starting at this place and ending with this place. And I'm going to go ahead and just decide I'm going to end with end inclusive. Just making that call here. That way it works for odd number functions. So whatever end is, that's the last bucket, including that bucket that I'm going to be interested in looking at. You can always choose to be exclusive of that, but then you'd have to write your dividers up a little differently. Doesn't really change it substantially, just a little bit different logic. All right. So I'm not worried about any other call to merge sort right now. All I care about is this array between buckets begin and end. That's the only problem I'm solving here. That make sense? So when is an array trivially sorted? Okay, yeah, when it's a one list. So when begin and end are the same guy, they're the same number, I have a list with one element in it. And when I have a list with one element in it, I would be wasting my time trying to sort that. It's already sorted. So I only want to do anything in here if those guys are not equal to each other, right? So if begin is not equal to end, if we are not dealing with the one list, that's what that question asks, right? If we are not dealing with the one list, then what do we want to do? Well, if I'm not dealing with the one list, I want to split my list in half, right? All right, so I need to have a begin one and an end one, and a begin two and an end two. I need to keep track of the beginning and ending of my two halves of my portion of the list. So I'm going to further subdivide AR into another begin and then another begin and end to give me two halves. All right? So begin one will be equal to begin, and end two will be equal to end. Those are the easy ones, right? Now I need a begin two. I'll fill it in a second. And we need an end one. So what will begin two be equal to? Let's go to our picture here. If I'm originally looking at, this would be my original call to Mergesort Helper, right? Begin is the beginning of it, end is the end of it. Well, now I need a begin one. And we said begin one is going to be equal to begin. And then we need an end two. And we said end two is going to be equal to end. Now we need a end one, and we need a begin two. Now, as a human being, we can visually say we want begin 2 to be here and we want end 1 to be here, but we need to mathematically solve for that. All right? And we need to solve for it in terms of begin and end. Because we are not guaranteed that begin is bucket 0. Begin might be the first part of the second half of your list. So begin might be a 2. And end might be a 7. Right? We might be somewhere in our list, not off the very beginning. So visually, if I want N1 in this case to be a 1, how do I get the value 1 in terms of begin and end? So n minus begin, which is 3 minus 0, which is 3, divided by 2, and it's integer division, so it'll truncate. Okay? So this guy will be end minus begin, and we need to put those in parentheses, and we're going to divide that by 2. So that'll give us the end of the first half in terms of begin and end. So we're writing this generically. This goes back to one of the slides we wrote a few minutes ago. Which one was it? We write functions generically, so it does not matter what the input is. We cannot assume that begin will be a 0. Begin might be way, way, way down. It might be almost to the end of our list. If we're dealing with the last 2 lists, actually, if we're dealing with the very last element, begin and end will be the same, and they're the very last bucket of our array. It's as far from 0 as you can get without walking off the array. All right? So when we're writing this generically, we can't worry about what value the thing actually is. We have to write it in terms of that for all potential inputs. We can think about what are the possible inputs. Like we know begin and end would not be negative numbers. We know they won't be, some number way off the end of the array or something like that. So we kind of know that we're trusting ourselves. I mentioned that a few minutes ago. We're trusting ourselves that we're going to pass the appropriate inputs into our function. Right? All right. So we can look at this particular call to Mergesort Helper and say, I am trusting that a few minutes ago when I called this guy, I passed it. Well, the easy part here is I passed it the original array. So if you started making changes to that array, you're probably doing it wrong. Okay, but if you're always passing that same array, that's the easy one. We didn't have to do any thinking. Just, here, change this in the parts where you're supposed to change it. But we had to be very specific about these 2 little integers. We're trusting ourselves that we're going to pass it the correct first start of this sub-array and the end of this sub-array. All right, so begin 2 is n minus begin divided by 2. Then what will end 1 be? This one should be pretty easy. Begin 2 minus 1. It's going to be the guy right before that one. So we've covered our bases now. Now, realistically, does it even matter here if we've divided up our list equally for merge sort? It actually doesn't. As long as we're dividing up our list consistently and we're not missing buckets. Okay, a common error in merge sort is you kind of leave somebody out, and then you have a list that looks almost sorted, but it has like this odd man out in the middle. Because you just never dealt with that bucket. He was never in a begin and end. He was just always, he was rounded out somewhere. Okay. Now, ideally, we do want to do it as close to half as possible, because that's going to give us the full efficiency of merge sort. Okay, especially, and I kind of mentioned it here at the beginning of class today, our computers today have multiple processors in them, right? We have, most of our machines in here have at least the dual core processor. Probably several of you have a quad core processor. And at home, you might have, anybody have more than a quad core at home? Like an octa core? Okay, so you're running AMD at home. Intel, you'd be running a 6-core at best, unless you bought something really, really, really recently. They now have a 12-core I don't know, i7 steroid something or other. But actually, in testing, they have. Does this keep flipping off?
Yeah.
Does it? Well, whatever. In testing, they actually have like 128, 256 cores and stuff like that, but that's on a big giant plate processor that they're not worried about heat. It's probably submerged in liquid nitrogen or something like that. It's once they put it inside of your laptop, they're wondering about your face melting off. So that's kind of becomes our limiting factor. All right, but punchline is if you have a quad core i7 processor, in his case he has an octa-core AMD processor, both of those have their equivalent version of this technology called hyperthreading. All right, which means that with his 8 cores, he actually has something called 16 logical cores. So he can sort of kind of do, we'll talk about this in the computer organization class, he can sort of kind of do 16 things at once. Okay, little hiccupy thing in there, but a quad core i7 can technically do 8 things at once. That's where things like Mergesort really become powerful, because we are splitting this work up, not on one processor. Where now it's scheduling for the CPU, and these are things we talk about in 325. But it's now getting, part of it's being done on processor 1, part of it's being done on processor 2, part of it's being done on processor 3, and that's all happening simultaneously. And Mergesort is compatible with that, because as long as we're sorting the one little piece of the array, we're not messing with any of the rest of it, right? So it's safe to have all of these things happening on different threads. Does that make sense? That's really weird, isn't it? Yeah. It looks like it's plugged in here. Now let's just keep trucking, because I don't want to. If I stop it, it'll break the recording. If I pull it out and plug it back in, there's a chance. If it gets too bad, we can try to pause the recording and do it again, but it seems to be coming back on pretty quick, right? So let's just roll with it for now, because it's not flickering on my screen. It's just doing it up there. Okay, so we have begin 1, begin 2, end 1, end 2. Actually, don't I have these guys? Well, here, I'm just going to, yeah, we need to have them in this order, so this is fine. So this is actually, I'm going to write this slightly different. I'm going to say that this is end 1, and we're going to say begin 2 is end 1 plus 1. Same thing. Okay. Just order of operation is pretty important here, and I wanted to have my begin 1 and end 1 kind of next to each other, and my begin 2 and end 2 next to each other. All right, so the end of our first half is end minus begin divided by 2, and that'll truncate to give us the end of the first half. And then the second half begins 1 bucket after that. Make sense? All right, so now I have my begin 1 and my end 1. So I have my portions of my array re-subdivided, because I do not have a 1 list. And since I do not have a 1 list, I need to call Mergesort Helper. So this dot Mergesort Helper, passing it my array, passing it begin 1, passing it end 1. This dot Mergesort Helper. Oh, Merse. Oh, I did call it Merse. I renamed it now. Here's my Mergesort Helper. That's actually from an old Seinfeld episode. The Merse, the male purse. All right, so we have AR, then we have begin 2 and end 2. Those are my 2 calls to Mergesort Helper. We don't have to worry about the recursive nature of this. I'm saying if I'm not dealing with a one list, I need to further subdivide my array, and I'll call merge sort on the first half, and I'll call merge sort on the second half. And merge sort will do whatever it's supposed to do. All right. When I finally get here, that means both of my merge sort calls have finished. Keeping in mind that each of those calls might have had more calls to merge sort, right? But eventually, I get back to this point. And what do I know at this point? The first half is sorted. The second half is sorted. I need to merge them together. So when I get to this point right now, I know through the steps that have gone on, through the result of these two calls to merge sort, which I don't have to worry about right now because they've done their magic. Eventually, both of those guys got down to a one list, bounced back up, and they did their own respective merge step where they kind of put the pieces back together for that little subsection of the array that they were looking at, right? So now when I'm at this level, I know that whatever begin 1 to end 1 is sorted in and of itself, and begin 2 to end 2 is sorted. And now I need to take that knowledge and build a single array that has all those pieces put in the right order. And that's my merge step. That make sense? All right. So now we can write this as a separate function if we'd like to. In fact, I'm going to go ahead and do that here. I'm going to say private void merge. This is going to take an int array AR, an int begin 1, an int end 1, an int begin 2, and int end 2. So I'll pass it the beginning and end of my two arrays. Does that make sense? All right, so with my merge step, what is the first thing that we do? Well, we're going to need a temporary array to house my answer. And then we'll just copy that back into the original section of my array. So how many total elements do I have here? What's the length of the subsection of AR that we're dealing with here? Where the first bucket is begin 1, and the very, 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 very last bucket is end 2. What's the length of that guy? AR.length is the original length of our whole array. We might be dealing with a very small subsection of that.
N2 minus begin 1.
Okay, so N2 minus begin 1 plus 1. Because N2 is inclusive. It's the last legal bucket of that guy. Right? So we're going to need an int array temp. And this guy's going to be a new int array. N2 minus begin 1 plus 1. That's the number of buckets we're going to need inside of temp to house all of the elements in order between begin 1 and end 2. And that's because we decided that N2 is the last legal bucket of our array, not one past that. So this is like s.length minus 1. It's the last legal bucket. So this is the actual length, the number of buckets that we need. Make sense? All right. So now what I need to do is I need to go and have a competition. Okay, I need to have a competition between starting at begin 1 and starting at begin 2 and pick and choose who's the winner. Now, how many total values am I placing? Temp.length, number of values. So the total number of comparisons I'm going to do is temp.length comparisons. Because I built temp in terms of all the elements I need to be able to hold here. So if I want to go through every element of temp, what would I do? Write a little for loop? That's our stock for loop. Goes through every element of temp. This is the number of times I want to complete something. And each time through, I'm going to put at bucket I in temp the winner between my current value in the left half and the current value in my right half. Okay? Now, so now I'm going to ask, which value is smaller? Begin one or end one? But I only want to ask that question if they're both legal values. All right? So how do I say that begin one points to a legal place in the first half of the list, and begin two points to a legal place in the second half of the list? If begin one is less than or equal to end one, if begin one is somewhere on his half of the list, and begin two is less than or equal to end two, begin two is somewhere on his half of the list. Now, I'm choosing to change my begin one and my begin two. I can create new variables called like pos one and pos two if I want to for comparisons and not change begin. If that makes you feel better, we can do that. We can say int pos one is equal to begin one, int pos two is equal to begin two, and then here we can say pos one, pos two. We're not going to need begin one. Actually, we will. We will need these. So it's correct to do it this way. Not change begin one and begin two. I was going to increment begin one and have it just keep working on the list, but we're going to need begin one and end two in the end. We're going to need those to copy them back over. So we'll just start with pos one and pos two. This is going to keep track of where we are in the left half, where we are in the right half. So as long as pos one has not walked off the end of the first half of the list, and pos two has not walked off the end of the second half of the list, then we want to, if they're both legal positions, we want to ask the question, if AR at bucket pos one is less than AR at bucket pos two. So if pos one is smaller than pos two, if the element that lives at pos one is smaller than the element that lives at pos two, what am I going to do? I'm going to set temp at bucket I equal to AR at pos one. Because pos one, this guy was the smaller of the two values. And then I say pos one plus plus. Because pos one was my winner, I've already placed that value. He jumps ahead in his part of the list by one. Else, pos two must have been the winner. Temp at bucket I is equal to AR at bucket pos two plus plus. Now remember, you could actually see something like this if you ever looked at online code. What does it mean when the plus plus comes afterwards? Good.
It adds a value after the condition.
Yeah, so when the plus plus comes after pos one, we get the current value of pos one here, and then we increment it. It has the identical function as that. As opposed to if I said minus minus pos one, I'm sorry, plus plus pos one and plus plus pos two. When the plus plus comes before, we get the incremented value. We increment first and then we get the new value, which isn't what we want. Because we don't know if the next guy's going to win. We just know the current guy won. So if you don't want to have to remember those things or you don't want to play with fire, just put them on separate lines. If you do that, then it doesn't matter if you say plus plus pos one or pos one plus plus. You pick your poison. Because we're doing it on its own line. We're not relying on which value do we get. Do we get the value before? Do we get the value after it? It just changes the value. That make sense?
Mhm.
So this is the way I would say you should write it. This is the way I would write it. And I promise you I understand the difference between plus plus and before and after. Nobody's impressed if you save a line. Okay, and I would say that's a pet peeve of mine of professional developers, where they like to write this really concise code that if there's an extra line, we need to take that out of there and stuff like that, and it ends up trending towards more error-prone code, in my opinion. Just put it on a separate line. If you have a great reason why having it on a separate line is a problem, fine. Then you could, maybe you're writing a program for an embedded processor or something like that, and you are really, really, really limited on the size of the actual file. Because technically, by putting in another line, we are storing a few extra characters, right? I had to store a carriage return character, plus I had to store another version of pos1 because it's a whole new symbol now. So it is a bigger footprint, but it's less error prone. So if you're trying to squeeze this guy onto a 32K of total onboard memory or something like that, you have a good reason for it. At that point, you probably are a experienced enough programmer where this isn't going to be a high risk. Yeah.
Does it change how it's compiled at all?
It would. Yeah, because if you have it up here, the compiler is going to deal with this statement as a single statement, as a whole statement. And it's going to go through and it's going to get this guy as part of that statement. It's a sub-statement within that statement. Whereas when you have it like that, this is a statement that gets processed. This is a second statement that gets processed. So it actually be a second call to the, I guess it'll be the parser and the linker to compile it. So it would not be identical for how it's getting compiled. It might end up being identical. I mean, in this case, it probably would be, but it wouldn't necessarily always be the case. But it might be identical at the assembly language level after all is said and done. Because you're only doing one instruction at a time, and what you're effectively saying is I want to get the current value, and then I want to increment it. So those would be probably the same 4 or 5 assembly language instructions, regardless of how you wrote it. So unless you have a great reason, I would write it like this. All right, so this is what I do if both pos1 and pos2 are pointing to legal places on their respective portions of the lists. Okay, if pos1 is the winner, I'll grab that value stored in temp at bucket I, increment pos1. I place that guy. Otherwise, pos2 must have been the winner. I'll place him, increment pos2. Else, if pos1 is less than or equal to end1, if I'm in this else here, that means that at least one of these guys was illegal. They were off the end of their respective portions of the list. They can't be the winner. Okay, so now I'm asking, if pos1 was the legal one, then what will I do? I'll go ahead and place pos1 and increment it. If he's the only legal one, he's winner by default. And then we increment him for the next pass. Else, pos2 must have been the legal one. So I'll place him and increment him. If both are legal, ask who's smaller. If only pos1 is legal, declare him the default winner, increment him. Otherwise, pos2 must have been the legal one, place him and increment him. Questions about what I just did there? All hard programs are made up of a bunch of easy parts. Is there anything crazy about the code I just wrote here? We see for loops. We've seen the same for loop that we saw since 200. We see if statements. We see less than signs and equal signs. Nothing's crazy about the code we wrote there. It just maps up to something that is a little bit more complicated, kind of a, but not even a crazy algorithm, right? We're just comparing some numbers and deciding who's the smaller of the various numbers. All right, so when we get past this for loop, we know that temp has in it all the values between begin 1 and end 2 in the correct order. So now I need to go back and copy the values from temp into that range of buckets in AR. So between begin 1 and end 2, I need to place these values. So I'll write another for loop for int I is equal to 0. I is less than temp dot length. I plus plus. I'm going to go through every bucket of temp. I want to place that value into the correct place in AR, starting at begin 1. Now I could have actually defined that inside my for loop here if I wanted to. I could say pause is equal to begin 1. So this is int pause is equal to begin. Is that right? Oh, no. I had it right the first time. It's just an error because I already have it here. So you can actually define multiple values inside your for loop if you'd like. Pick your poison. It's not going to matter here. So I'll actually just write it this way. That way we keep a pretty stock looking for loop. So pause is going to keep track of where I currently am in my AR. I is going to keep track of where I currently am in temp. So I'm going to say AR at bucket pause is equal to temp at bucket I. I will automatically increment here, but I'm going to need to increment pause here to keep it moving down the line in AR. So what does this do? This guy copies the values from temp back into the correct portion of AR. And remember, arrays are passed by address. So when I overwrote portions of AR, those had permanent side effect in the rest of my program. I changed values in memory up there when I overwrote into AR. Got it? So that's what my merge step does. So back in Mergesort Helper, when I get to here, I'm just going to call this dot merge. I'll pass it my array. I'll pass it begin 1, end 1, begin 2, end 2. He'll do that merge step. Everything will come back together. And then this call to Mergesort Helper ends. Notice in Mergesort Helper, I'm only ever doing all this crap if I'm not dealing with a one list. If I'm not dealing with a one list, do all this stuff. If I am dealing with a one list, it's already sorted. Don't need recursive calls. I don't need a merge step. It's a single element, sorted. It's good to go. Make sense? Mergesort Helper requires me to give it an array and a begin and end. So I need to have my original call to Mergesort Helper, which is going to be up here in Mergesort. So this dot Mergesort Helper, I'll pass it AR, I'll pass it 0, and I'll pass it AR.length minus 1. And I think we already have our buttons for Mergesort. Yeah, this guy right here. So, if everything went to plan, there's my random numbers. What row?
You have to do more with the actual merge sort call.
I don't think so. Let's see what he's upset about. Right, I'm guessing he's complaining about a Stack Overflow exception. Yeah, Stack Overflow. So we have an infinite recursion call here. So we call it begin one, end one. And that's my Mergesort Helper. As soon as they're... Oh, hold on. We need to... I almost guarantee it's while begin is less than or equal to end. Because I bet you the way we did our math here, they end up crossing over. They don't equal each other. We end up getting a end that is actually before begin. So as long as begin is less than or equal to end, let me just run it real quick and I'll show you why that's the case. Nope. All right, so we're going to go into our debugger here and let's see what he's not happy with. Because it's definitely this first call, begin one, end one. Begin to start at begin. End is end minus begin divided by 2. That should be n1. Begin 2 is that plus 1. Yeah, that all looks reasonable to me. So I'm going to just put a breakpoint right here. I'm going to go to the debugger. Let's just look at what begin and end look like there. Oh, end is 99 because I have 100 buckets. That makes sense. Okay, so begin is 0, end is 99. That sounds reasonable to me. I've shown you the debugger before.
No.
Yes, I absolutely have. No.
No.
I remember earlier this semester, I specifically showed you the debugger in this class.
No, you showed it to us, but never actually ran it.
Are you lying?
No.
I've never seen the green.
I never seen that before in my life.
This is cool.
I think you probably said.
No, I have a really good memory. I'm positive I showed you this debugger.
I'm pretty sure you showed us how to. I'm positive you don't.
I used it. I would not have shown you how to use it.
No. I'm positive you don't. Otherwise, I would have done my homework yesterday. Using it.
Well, no, I mean, you don't have to use it this way. You could just put print statements.
That's what happened.
But
This seems so much easier. You just highlight and run it.
You don't.
No, I've shown this before. I'm
No,
positive. I am positive.
I'm positive too.
I realize that as a group, it's more likely that you're right, but I have a really good memory.
Are you sure it wasn't a different class?
If I didn't show it to you in 300, I showed it to you in 250.
No.
It's in the this group. It's this group.
I remember you saying debugger, but I don't think you've ever run it and shown us like.
There's just no way I would say it and not
never,
run it.
Printed out green like that before.
Yeah.
Oh, I think this might be updated because I didn't expect it there. I expected to see it down here.
Oh, that's probably.
Yeah, I expected to see the output here. I've never seen it up here like this. So I think that might be something new. Maybe that's what's impressing you. There's no way I would mention the debugger in class and not run it. That's an impossibility.
Seems kind of crazy.
All right, so in any case, these guys are the same, right? This looks reasonable. Begin is 0, end is 99, everything looks fine. So we definitely get into that if statement there. I do the step over thing. Now I'm actually going to,
That's so cool.
what's this? All right, so now I'm going to hit this button that just runs to the cursor. So I'm going to let it do its thing. So now I'm on my first half of my list. This is begin is 0, end is 49. So that's my first call. That looks like the first half. All right, so we definitely get into that if statement. I'll run it there again. Now we're at begin is 0, end is 24. We're at the first half of that list. Hop in. We're in our list. This is nothing you couldn't have done without print statements.
Oh my
You
God.
could do this with print
super
statements.
So cool.
You're not wrong.
Like,
All right. So now we'll run it again. So they're still not dealing with the one list, right? So there's begin is 0, end is 12. Everything seems fine. We definitely get into this guy. Begin is 0, end is 6. Definitely get in. Begin is 0, end is 3. Definitely get in. Begin is 0, end is 1. So we're still dealing with the 2 list here, right? Okay, so I think we're about to stumble on where our error is. So we'll step in, run it again. Begin is 0, end is 0. So while begin is less than or equal to end, we should not get in this time. Oh, because it's, yeah, because it's equal to. That's the one list. So this should just be less than. So I had the right rationale for you, but the wrong fix. So now I'm running it normally without the debugger. Oh, still the issue.
Just run it with a second list.
I'm going to.
Like, oh, I got stuck right there.
All right, I'm just going to bump ahead till we get to our... All right, so this is where we last were. Oh, we were right here, actually. All right, so we see that we skip past that, right? So now we should see our right call for the right half of that 2 list. So we should see bucket 1, bucket 1. So there's bucket 1, bucket 1. So that should also skip. So now we come back together and we should be past our 2 calls to merge sort, where we have a 1 list and a 1 list that we need to now merge back together. Oh, I need to, let me do a stop here. Okay, well, notice we're seeing our list right here. So it's actually changed 99 and the 164. Because it already did the merge step for that previous one because I didn't have a stop in there.
it's displaying me, right?
Right here.
What?
Oh my gosh, that's so cool.
All right, so I'll run it to the next thing here. So now we have a begin 2, end 3. So this is our second merge sort call for our first, not first half, but our first left 4, if you will. So that guy looks fine. That does not look good. Begin to end. So that was...
I got stuck right there yesterday. That's why my focus is running. Keep doing it.
This, I'm thinking, is where our issue is.
And one, I have very similar if I had plus begin.
Oh, it is that. It is, and it is plus begin. This is what happens when we take V's word for it.
Oh.
V wrote this line for us.
I'm sorry.
So we got to roll back 20 minutes here. Remember when I said we have to write our position in terms of begin and end? If we say end minus begin, okay, we're not getting the full range of our array. End minus begin gives us the full list. Divided by 2 gives us what that half is. All right.
Mine is broke.
No, this is good though. Thank you for having us do this.
Because then you got to see the.
Even though I was able to show this.
That's why my car broke yesterday.
So there's your merge sort.
Oh goodness gracious me.
Does it work with the not equals now?
It probably would. Just because I think it's safe the way we're dividing it. But less than is not a problem.
Yeah.
Actually, it should work anyways, because even if they flip-flop, they're still not equal.
Mm-hmm.
So it should still work.
Oh, now I figure out why I got wrong yesterday. Just because of one symbol.
All right, so I'll just finish talking to you about the debugger here. So notice I put these little stop. Okay, here. I'm going to put it. I'm going to challenge you. I will give whoever can bring me up the video where I did show you the debugger. I'll give you a free quiz, which is equivalently a free 100 homework assignment. So if you did poorly on some homework assignment, you missed a quiz, go and scour our videos. I'm pretty sure. Well, you could just drag through until you start seeing dots and stuff like this. I'm pretty sure it was this semester. Early on in the semester, but it's possible it was last semester. But it happened with this group.
Oh, I'm pretty sure.
I honestly thought like the red line was like an error thing first. And I realized
Being
recently.
mentioned, but I don't remember seeing it. That's all I'm gonna say.
Yeah, I never see it.
It's
Yeah, there's just no way I would have mentioned it and not shown it.
Hang on, push it.
This is better now because it does show you this stuff up here in real time, so it's a lot easier to look at than having to constantly glance down here. So they've improved Android Studio's debugger, but the data was available to you, 100%. So if anybody wants to pick up that mantle for a missed homework assignment and go find it, well, don't do it right this second.
What if we find that there's not one?
What's up? What if you find out there's not one?
Yeah.
Well, then you're no worse off. You could have just used print statements.
Yeah, but I mean, as far as
Statement doesn't work because it's not.
What do you mean? It would have worked.
Yesterday it's crack on me
Well,
because I got the wrong symbols and they were actually going and then just crack for some reason. I don't know. I turned my homework. You can take a look.
But you could have. Okay, hold on. Let me show you. So let me finish explaining this, and I'll show you how you could have made the equivalent of this with a print statement or with print statements. Okay, so what I did here is, if you're over here on the left margin or whatever, you can click, just left click, and that turns on a breakpoint, turns off a breakpoint. You can also right click on this, and you can, no, that's not what you want to do. So this will just turn it off or on. Any place you have a breakpoint, your program will pause there. Okay? So you can put multiple breakpoints in. You can say, I'm interested in this and this and this. You know, you probably wouldn't do that. You'd probably have it on the outside of your structures here. And then you could walk through line by line. Now, once you set breakpoints like this, make sure when you run it, you click the little bug guy here. And the thing is, I specifically remember telling you to click the bug guy.
No.
This happened. Luke's going to get extra credit. You just watch this happen. Hey. My memory is not as good as it used to be, but I have an eidetic memory. This happened.
Hang on. You said 5 videos. Does it include this one too?
No. Before today. Before today.
Otherwise, I would have turned it in.
Do I have to go back into 250?
It's possible, but it was definitely this group. It was definitely this group of students.
My fish brain is not.
Okay. If it was in 250, it was post midterm.
Yeah.
So it was near the end of 250 or you know,
We only
early
had-
on in here.
Yeah, we only had one assignment for Visual Studio and it probably wouldn't be that hard.
No, is that true?
Yeah, I think so.
You only have one assignment in Android Studio in 250?
I think so, right?
It was good last year.
Like we talked about it, we talked about it a lot, but I think we only had like one actual.
Let me check something here real
I
quick.
could be wrong.
It's possible I showed it to you in Eclipse, but I don't think so.
No.
The debug, no.
That's the
I'm
first
almost
time I
positive.
see it.
I mean, well, first of all, let me just show it to you in here real quick because it's the same thing.
Oh, okay.
This isn't like a special Android Studio thing. Visual Studio in your 370 class has a debugger. Works pretty much the same way. You click on set up breakpoints on the left-hand margin, and then you can, you know, run it as debugger.
I don't know it either. I don't know what he's talking about.
Well, then,
Forget it.
Well, here, I'll just run this in the background while I'm doing this. Yeah. So,
there's some-
oh, here it is. Yeah, the little bug guy. So you do the exact same thing and click on the little bug guy in here, and it'll do the same thing. It might look a little different. You have to kind of hunt around in your interface until you see where it's doing the debugging thing. Okay, but so let me just show it to you here. I think I'm already running it in here. So I'll go ahead and hit merge sort. It dives in here. Now we have these controls down here. So this one is step over. So that allows you to step over the current line. There's another one that says step into. And what that does, I'll actually show you how step into works. So I'm going to step over, step over, step over, step over. So notice each of these is giving me the values at that line. This is actually pretty nice because it's showing you, I mean, this is a major update because it's showing you the values up here next to each line. Usually you have to look down here to see all your values. And then see this array is here, but you can open it and see the array. That's been there forever, that type of stuff. But showing it up here is definitely new. That's pretty nice. So I'll step over here. So now what I'm going to do is I'm going to step into that. That brings me to my next call to merge sort. We actually would have gotten here anyways because I had a breakpoint there. But stepping in says I'm going to keep following this linear line. And now I'm stepping into that Mergesort Helper function. Now I can step out of a function as well. So now I'm in my next function call. I can step out of that guy. I'm in my next function call. And so on and so forth. So notice by stepping out here, I'm not getting to this merge step yet. I can also turn that guy off in real time. And then I can hit this button, which will run to the next cursor. Oh, you won't let me turn it off in real time? Oh, is it because I'm stepped in? Let me step out. There we go. That's because I manually stepped into the function. I had to get out of that function in order to. All right, so now I'm to my call to my merge step. Now, if I want to go and watch this merge step, because this guy is not a, if I just say step over, it'll show me the result of the merge step. But if I want to follow my merge step, I can click on this and step into it. Now this is taking me through my merge step. So I can watch this guy, and then I can step over, watch one line at a time if I want. Maybe if I get past, like, oh, I was a little bit, wasn't sure if this was going to work right. Now I'm happy again. I can go ahead and run back to the cursor. I got to step out again. Then I can run back to the cursor. There we go. So I'm at merge.
Do you know why there would be a debug on the bottom of your screen?
Debug at the bottom.
But, I mean, like where you push debug, why wouldn't that be there?
You might need to go
So I went to
to.
view and toolbars, but then it is kind of like blocked out. You go to view and
Make sure you're running it with the debug guy on.
Maybe you have to hit the bug first.
You might have to start it in order for that to be an option.
okay.
All right, so questions about this stuff? And then we can, well, here, I need to step out of the debugger here, so I'll just restart it. So there's my merge sort, there's my insertion sort, reset, this, merge, whatever. All right, so we're going to add one more ability to this. This is going to be more of an interface thing. Right now, I'm automatically generating a range of numbers. So I'm generating 100 numbers, right? So what I want you to do is I want you to add inputs up here for the number of numbers, the smallest number, and the largest number. Right now, I think I'm doing what, like 1 to 1,000 or 1 to 500, something like that. So you should be able to say, I want 45 numbers between 1 and 7. And then have it generate those, and then insertion and merge sort should still work. You won't have to change insertion sort or merge sort. We're adding a functional ability to our interface. So for Thursday, you want to be able to take 3 inputs in your program, how many random numbers, and then the range of those random numbers. That make sense? If your merge sort didn't currently work, make it work. So you can follow what we did today. So it should still work. Your insertion sort and merge sort should still work, but if you have my code now, it will work. Make sense? Questions, comments, concerns, bribes. Today's student, faculty, staff Bible study, God and Grub. Go to the cafeteria, sign in, grab your tray, take it down to the terrace room from noon until 1.
Are you gonna be at school tomorrow?
Yeah.
If I cannot make